Just because it's a new part, all that means is it's a new part. That doesn't mean it's a good new part, it just means it's a new part. Okay guys, welcome to the shop, and we are always looking for a good opportunity for good content, things that will help educate, things that might save you money, and this is definitely a good opportunity for this. So again, it's kind of the nature of our videos are very impromptu. As we maybe find something, we immediately want to take the opportunity, like I say, to address this with a video so that we give you good content. That being said, we are going to talk about thrust bearings today, and if I've beat a dead horse, it's definitely the ideas of qualifying a part versus buying a new part and thinking that they're synonymous. They're not. They're completely different. So that being said, this is a perfect example. We have a crankshaft that's been measured, it's been balanced, it's fixed to be in an engine for assembly, and with that said, the next thing we're going to do is we're going to grab the bearings out of the box, and we're going to start putting them in the block. We're going to torque everything down. We mic the crank. We're going to check the difference between the block. So we're checking our clearance amount. So while we're doing this, we are looking at the bearings, verifying that our oil clearances are where they should be. So one of the things about our bearings, one obviously is different than the rest. It is a thrust bearing. Now what a thrust bearing does is as the engine is going down the road and the truck's going down the road, one thing that's happening on the crankshaft is it's actually trying to be forced out the front of the truck or the vehicle, and the reason being is because of the torque from the rear end. Everything is being pushed forward. So to combat this, especially when converter lockup or a manual transmission, every time, you know, if you push in on the clutch, you're pushing, the pressure plate is actually pushing in on the back of the crankshaft itself. It's trying to force that crank, like I said, through the front of the engine. If you had excessive walk in the crank or axial play, you'd wind up having oil leaks. So we have a thrust bearing here, and what the thrust bearing looks like on this particular engine, this is a 6.4 liter, but on this engine, or excuse me, this is a 6.0 liter, which actually uses the same thrust bearing, but I can see the difference in the crank. But anyways, this is a one-piece design. So what happens is this surface right here is going to go against and mate to the surface right here on the crankshaft, the thrust face on the number 4 journal. So what is extremely important is a couple of things about this. One is definitely surface finish. I'm not going to get into that so much on this video. Another is perpendicularity between the journal, the face right here, and the surface right here. So we've got a surface here, here, and here. They need to be perpendicular. These two surfaces here need to be perpendicular to the journal itself. Now, it is extremely important that we have proper clearances. If we don't have the right amount of clearance between this face and this face here, what will wind up happening is the bearing will actually spin in its housing, okay? So there needs to be, what we're looking for is about 3 to 8 thousandths clearance. How we check that is we will load the bearings in, we'll torque everything down with the crankshaft in, we'll apply force to bottom out the crankshaft in one direction, and then we'll put an axial dial indicator on the end of the crankshaft, and then we'll move it the other direction and see how much axial play there is. Now, this is a bearing, like I said, brand new bearing that's pulled right out of the box, and one thing that you'll note is they had found when they did that test that there was absolutely no clearance. There's no in-shaft play, that's what we call it. So if you'll see, we actually have to force this thing down here. It's not going down. It should just basically be very, very light touch. I have to actually put some force behind it to actually get it to go in place. Now, we've measured the clearances here against the thrust face, and they're within spec. They're where they should be. But there's a difference in this bearing from this one to another one we pulled out of the box. So the problem is just the bearing. Now, that being said, that goes back again to qualifying the part instead of just assuming that a new part's good. Just because it's a new part, all that means is it's a new part. That doesn't mean it's a good new part, it just means it's a new part. Especially in an engine building, it's extremely crucial to qualify these parts. Had we put this bearing in, there would be no oil clearance between this face and that face. It would have spun the bearing and it would have wound up causing complete failure at that point. So the question goes back to, should I have my machine shop just build my engine and, or excuse me, just do the machine work and I'll assemble the engine? The thing is the machine shop is not going to check your new part against that crankshaft. That's not their job. What they're going to do is they're going to grind the crank. They'll make sure that the faces are within tolerance, the journals are within tolerance or within spec, but they are not in charge and they are not responsible for any parts that you buy to put on there. If the guy's going to do this, he might as well assemble the engine, because that's basically how we're going to check it. Putting this in the block and again checking the play. So a lot of guys ask me all the time, should I just go ahead and have the machine shop do the work, or should I just get a long block from you? This is the reason why we can provide a warranty, because we can verify these things. There's a lot of things that we do to test, also not just on a bearing. A couple of things you have to think about. There's a certain amount of crush that's involved. So there's another bearing that's going to sit on top of this to keep it from spinning in its bore. There is a certain amount of crush that has to be forcing down on this bearing in order for it to remain in the bore without spinning. If it for some reason was manufactured with the improper crush load here, it can spin. So there's ways that we can do, things that we can do to verify that, putting it up in a jig and actually bringing this surface down flush, finding out what the protrusion is. There's different tools that we use, that we make here personally just for our own use. But there's a lot of things that are going on with the bearing, a lot more so than what an average person would think. So again, just wanted to bring some awareness to this, and thank you for watching. We hope this has been an educational and eye-opening for you.